Welcome everyone to this session on lesion tracking DICOM's senior to SR to FHIR mapping. Speaker today is Dr. Khaled Younis, and he's going to start his presentation now. Khaled, over to you.
Thank you. Hello, everyone. I'm very excited and thrilled to be at DevDays, which is the community for FHIR. This is my first time here, so I am very thrilled of the experience. And today I will talk about lesion tracking, and we want to talk about how we can map the DICOM SR, DICOM structure report to FHIR resources. I am Khaled Younis. I have a Ph.D. in computer engineering, and I work for Philips as a senior research scientist, working on integrated diagnostics, informatics, and I also have the pleasure of representing Philips in many standard developers organization. The one that I will highlight today is HL7 Imaging Integration Working Group, which is also DICOM Work Group 20, but I also work in the IHE Radiology Technical and Planning Committee, as well as I'm a co-chair of the SEM, Society for Imaging Informatics in Medicine Research and Tools Subcommittee. As a disclaimer, even though I am the speaker, but I present the results of the working group 20, as well as my colleagues at Philips, Bob Peters and Roel Troin, as well as Nikhil Sonar. So this is the presentation outline. I would like to go quickly about the imaging integration work group project that we have, and we need to give some awareness of that work, because really an imaging integration work group, we depend on volunteers who are experts in the field to help us and enable the development of this project. We have a week, every other week meeting on Tuesday at 11 a.m. Eastern Time. And if FHIR developers like yourself, whether you are attending in person or joining through the virtual platform, we really appreciate if you can join force and help us develop this work. I will focus mainly on the TID 1500, because it is actually the primitive that was highlighted by the IHE AI results profile, and it can actually represent so many of the results that are important for analysis. It can represent observations, measurements, it can represent graphical objects, so that's why we want to talk more primarily about TID 1500. And we are using the latest FHIR implementation, but we are very anxious, waiting to have R5 available, because we at the Imaging Integration Working Group have developed also a new resource called imaging selection. That will come in handy when we are talking about groups of images rather than the whole imaging study. So as I said, we will talk about V4 implementation, but in the mapping website and GitHub and the build, you will see that we also work on resources that require V5. So we have collected a sample data set from the Cancer Image Archive to look for lesions, and so that we can track it over time. As you know, it's very important that if you have, for example, a pneumothorax detected in the chest X-ray, that we monitor that. Is it increasing in size? Is it diminishing? So for that we need to track the measurements or observation over time, and that concept of lesion tracking is the focus of this presentation, even though the whole concept can be used for different kind of AI results. It doesn't have to be imaging at all. It can work with any data that follows the structure report once we convert it to FHIR. So I will show some mapping diagram that helps spark a discussion. I hope this is not a lecture. I might be the least experienced person on FHIR here, so I would really appreciate the discussion and contribution after the presentation. And I will describe one item that we think is crucial to the mapping, which is the tracking unique identifier that can represent the same entity over time, as well as if we are using a different acquisition technique or parameters to track the same entity. So we will use the focus field of the observation resource to refer to the body structure identifier in that sense. So why is this important? As you all know, we depend on the input of the modality, whether it's a CT, ultrasound, X-ray, and that's usually is represented in DICOM. And DICOM is, as you all know, well established, and therefore most of the measurements are represented in DICOM, and then we use whether it's an AI algorithm or advanced image analysis algorithm, such as maybe annotation done by radiologists or any image processing algorithm. Usually, if they follow the standards recommendation, they will represent that as a DICOM SR object, and that can be sent to the PACS for archive and the viewer. What we want to do here is to map this to FHIR resources so that we can develop an intermediate platform. We call it AI results, that will take the input from all of the AI vendors, regardless of the format that they use to present their finding, and store that in FHIR. And the FHIR here that takes all of these input, whether it's a pre-read or clinical summary or AI algorithm, can be used to filter the results, or maybe examine them for acceptance or rejection, or maybe change the annotation, and all of that before it is sent to the reporting system. But the mere fact that we are storing everything in this FHIR, that will enable a lot of the use for smart diagnosis and access by different systems. And here we're talking about EMR, pathology systems, so that we can support all the multidisciplinary care team. And then this can be also used for analytics and AI retraining in case you notice that there is a difference between the output of the AI algorithm and the annotation of the radiologist. Is there any question about this diagram before I move in? So I will now talk about the FHIR Connectathon that took place last month, and it was sponsored by the Imaging Integration Working Group. So I explained the problem. So this is only for your information. I will share the slides, of course, after the meeting. But we think that it's important that utilize the HL7 for interoperability. And we want to highlight the observation resource, as we think that for our purpose, it's the most appropriate resource. Even though we will be using imaging study, patient, we have to refer to a device that is the representative of the AI algorithm. But you see that the main goal here is to bridge the two standards, the DICOM and FHIR, to map this observation. So the DICOM world is very huge, so we need to focus, and that's why there's this scope. So we want to focus on these two aspects and discuss the mapping. So usually when you have a DICOM SR that can contain several observations, it can represent, for example, different lesions, and for each lesion, it can describe the volume, short axis, long axis, and even some qualitative assessment of the lesion, like the morphology, the margin, and other aspects of this of the lesion of interest. So this is the website for the current draft. It's work in progress. So that's why it's important to have discussions and the community involvement, as I described. So this actually shows the mapping overview. The TID 1500 contains usually one of three, or they can contain, all three of them: qualitative evaluation and derived measurements, imaging measurements, and the imaging measurements, and that usually is represented in certain templates like 1410, 1411. So the goal here is to map all of these to the observation, and you can see here we can have as many as we want. Some of the observation can be marked as a root observation or core observation because it kind of identifies the main lesion. And for this, we need to link that to the imaging study. It is part of the imaging study, and the subject is the patient. This is how we link the different measurements to the patient, as well as we need to know who is the performer, practitioner, and what is the AI algorithm that developed that. As I mentioned, this is very important, is the body structure is the one that will identify the area of interest or the real world entity that we want to track over time. But the different measurements, as I said, it can have ROI measurements, it can have volumetric measurements, and it's shown here, even though it's not implemented yet, but this is the imaging selection aspect, because usually when you want to show the radiologist that you are deriving certain parameters, that means you need to specify kind of a range of values. So these are the different measurements that I told you about. And this is the topic of the imaging selection that we are very, enthusiastic about. It has demonstrated that it is very useful. We developed at IHE a new profile for IMR, which is interactive multimedia report. And for that also, you need to reference a selection of images, and that's why they are also using this imaging selection. As I mentioned quickly, AI algorithm is not a resource in FHIR, so the most appropriate is the device resource. And so that is what we have. And as I said, it's still a work in progress. And this is the Confluence page that describe our work, so that if you want to go here and look at the details of the mapping, then this is where you have like a very clear instruction how to do it. I want also to discuss show you basically what we have done. So we have developed an implementation resource that uses a Scriban template for actually doing the mapping. So for that, we identify the mapping specification in this. And so this is a directory that includes the mapper that was developed by our colleagues. And you need to specify the input JSON, and it will immediately generate the output bundle of this DICOM SR input. As I said, Scriban is a nice templating language that is available online, but we utilized actually the in-house version of it, so that we don't need to send the data for the cloud if it's sensitive. And this is the output of, so this is the, for example, the input, which is just a JSON representation of the DICOM SR, and this is the output. As you can see here, we have different observations. I don't know if we need to zoom in, but you can see here, this is a bundle. It includes the patient basic information, it includes the imaging study, and then it will start with the observation. One root observation, and for that root observation, it will have other values or other minor observations that are linked by has member. And I think we are almost at time. So if you have any question, please feel free to.
Thank you, Khaled.
You're welcome.
Great presentation. Thank you.
Thank you.
I just had a quick question. So, almost a decade ago at this point, we did some, when I was in structured documents working group, we did some work porting DICOM SR to consolidated CDA. And later when we created CCD on FHIR, we ported that work over as well. So I wanted to see if you were aware of that and did any look at it. We didn't go down to this level of detail though. We just pointed to generic observations because there were no existing profiles and we didn't want to create something as structured documents when you guys should be doing it. So if you hadn't looked at it before, maybe suggest that you contact some of the folks at Structured Documents and file a JIRA tracker so that when next time we update it for FHIR R5, we can include this work in there. Because then you have the full textual representation as a composition resource that would point to all these details down below, which I think would be a great way to actually get people to implement it.
Well, yeah, thank you very much. That's the beauty of having HL7 and the FHIR community here so that we can know of your previous work. And for me, this is new. I knew that there were some initial work, Brian Bialki, from ACR did some work, but he was using the document reference. And then also there are Project Week, and they had tried that before, and they came up to the conclusion that we cannot do bidirectional mapping to FHIR and back to DICOM. So it was very interesting also finding, but still the more we get input, the better. And I will look up what you suggested. Thank you very much. Yeah, so maybe there are new co-chairs. Jonathan Whitby is actually leading this work. He's from Canon, and Chris Lindob from GE as well, who is standards guru, on other question?
We seem to be almost out of time. There's going to be another session in 10 minutes. If you have any questions, quickly, go ahead.
I was going to take this offline, but we did, there's an IG, an accelerator called Codex with a implementation guide called MCode that did tumor size. It's not specifically imaging, but it's transmitting tumor size to oncologists, to track the same thing that you mentioned. So I'll just take this offline because I know we're over time. Yeah. But I did want to point that out, and there's been a lot of participation from imaging companies and radiotherapy companies as well in that effort.
Yeah, that's really good. As I said, we're not only focusing on tumors. We will take any observation, even if it's not related to imaging, as a matter of fact. But yeah, the fact that there is a specific solution for tumor, I think that will help us a lot, because until now we are struggling with the proper representation of some of the fields. So if we look at what you have worked, then we might get some insight.
Thank you so much. We are out of time, and there are questions in Hua. I'll send the questions to Khaled, and so that he can answer them later. Thank you so much, Khaled.
Yeah.
Thanks, everyone.
Thank you.